Hey everyone, just about 7. Go ahead and make a point if you got to make a point about something. We'll go ahead and get started. There are a few cars pulling in, but they can catch up with us. We'll do the usual of a few minutes about the club itself, and then I'll jump into the presentation on planetary defense. And thanks again for coming out. This is easy to blow off, and that you're taking some danger, so you all got here safely, and too, when we break, everybody take your time, sort out the umbrellas, and be careful going home safely as well. Okay, a couple of recent club events. Last month we had Jeff come out and talk about the Osiris mission, as well as a few other asteroid missions. One data point on that is they designed that satellite, and they spent years designing it and engineering it and building it. They thought that that probe was going to go about 2 inches into the soil, and it went about 19 inches. So it was Bennu was much softer and lower density than they had calculated by almost a factor of 10, which is going to be kind of relevant to the rest of the discussion tonight. And then the field trip, we had 48 people go. How many went on the JPL trip? Good, about half here maybe, and you got your souvenir name tag, and that was a really nice day. It worked out really well. The weather cooperated, the timeline worked out, and you could see a couple highlights here. I was with Nikki's group. I don't know about there were 3 tour guides, so 48 of us got there, and then we did a joint presentation. They did an auditorium presentation, a little speech, and then we broke up into 3 groups and went around. So if you weren't able to make this trip, we're going to probably do it again next year to pick up people that weren't able to come, and I think it's definitely worth it. That's really, if you want to get philosophical on it, JPL is like the mecca of space exploration, and it's an hour and a half up the road from us. So I think it's definitely worth the trip if you've never been there. There's Eric, there's Stuart, telling her that the universe is much older than 13 billion. They got the numbers wrong. And then if you know right here, I want a big thank you to Robert Cunningham, who videoed a lot of the trip and put it up on YouTube. And we have over, 120 views. So twice as many people that went on the trip have already watched it online. But if you want to make a little mental note or write this down and look at it, again, whether you went or didn't go, you can go to YouTube, and he starts from getting on the bus to the park to going through. Really nice job. In fact, can we get a round of applause for Robert for doing that? Thank you. Really helpful to the whole effort. And then last Saturday, the people that went to Casper's, I had to go to San Diego, I didn't make it, but if you look at these 2 images, that's Andromeda and the Orion Nebula. We have Stuart did some networking with a NASA engineer that has an educational program with new synthetic telescopes that are basically one way of describing it, they're more powerful than traditional telescopes, and it's processed data. So they basically look at the photons coming in, process it, and if anybody's been to Casper, you never see these like this through a telescope. That was from a $500 synthetic imaging telescope that NASA has loaned to our astronomy club for several months now. We were hoping to run it tonight, but the weather didn't cooperate. All future meetings will probably have it right out here. And when we look at the sky with our own eye, you don't see half of what this device is able to digest out, and we'll display it on a big screen out there. It should be pretty fun. And this is the last presentation for the year. So our last big event is next month. We'll have about an hour and a half at Clubhouse 7. If you can come, please do. And RSVP to this email, or make a note if you don't use email, to let Chris know that you intend to come so we get the right amount of food. But Clubhouse 7, they have a nice sundial, and Chris is here tonight. She's our yoga specialist who will give us a little connection to the universe to get started. We'll have a nice meal and just enjoy ourselves. No big agenda. We'll probably put together a year in review slide deck that'll be running, and just kind of see where we did on this orbit. And then a very talented local person will be playing acoustic guitar and singing for us as well. Should be a fun day. Or fun afternoon on the shortest day of the year. So here's a bird's eye view of where we are. We had a really nice, and basically since Chris Stewart and I got engaged 2 years ago, this is our second orbit. We had 13 events. That was a really fun track. Here we are tonight. I'm going to finish up the information sharing, and then we'll have the winter solstice party, and then then we'll kick off the new year. So hope everybody enjoyed this orbit around, and then can sign up and keep your support of the club, and we'll have a nice 2024 as well. And here's what that looks like right now. It is, again, Stuart did some good network. We have a NASA Mars engineer that's going to come talk to us about what they're up to, looking in that direction. That should be a good lead-off presentation. And then if anybody remembers Ruth and Rich that came and spoke about the James Webb Space Telescope, they're going to talk about the new mission of the Psyche investigator that's going out to the Psyche asteroid, which has some unique characteristics. And then we'll have other presentations, field trips. Griffith is on the target list. We haven't locked in any dates for sure, but we'll lead off with the planetarium right up the coast, and then a couple other nice sites. So 2024 should be a lot of fun as well. Okay, so there we are. Thanks again for coming. We'll jump over to the other presentation, if the IT gods are cooperating. Planetary Defense. What a great title, and how this, I forget when I first heard that NASA stood up this Office of Planetary Defense and their mission, but it seemed like a very interesting topic. So I guess over the summer I did a little thinking about it and took some notes and basically looked at some websites. There's a lot of good content. If you go to YouTube, you can find information on it. But I read a couple of their documents, including their most official document of April of this year. They came out with their strategic plan and action document. And I read, it's about 50 pages long. I read through that a couple times. And basically most of this content is based off of that. And that's what we'll be discussing. So our goals is, there is a threat out there. There's a lot of threats to life, but we're trying to blow ourselves up pretty effectively. There could be natural disaster, Wyoming, the Yellowstone. This isn't geological, and we're not looking if the sun blows up or if we blow ourselves up. It's basically about asteroids and comets that we realize are out there flying around and hitting us every day, and could have a larger impact than that. And then better understand what NASA's doing to address this effort. And then the main thing, I think, is let go of your daily life and do some brain exercise. I have a few conceptual things in here. In fact, the introduction has some big picture type stuff. If you can kind of flex your neurons and try and think about what we're dealing with, because it's easy to just feel like it's too hard to comprehend when you look at the numbers of space and time that we're dealing with. It's really an amazing time to be alive. So with that, like I said, the introduction will be 4 or 5 slides on the big picture of where we are, a little orientation. And then we'll look at the threat in more detail and better understand it as we described. And then talk about what NASA's doing to address it. And then the assessment, this is my assessment based off of the looking at it that I've done. So you may have a different conclusion, other people might have a different conclusion. I may be missing relevant information. These slides, this is the first time I put this deck of information together in this group and the first time I presented it. So there could be errors and omissions in here, so take it with a grain of salt, but again, if you can kind of reflect on it and see what you think. And then based off the assessment, I have some concluding thoughts. So the introduction, on top of everything else, we got to worry about some big fireball coming down and blowing us up. And here's a little mental exercise though. If you see that green automobile right there, think of that as a car. And I've had this thought for a bit, but as far as our consciousness of where we are, if you think of the Earth as a 4 billion year old car, for the first billion years there was no life whatsoever. It was just driving along and there was nothing, as far as we know, our best estimate right now. is that there was no life, and then down at the smokers 2 miles under the ocean may have been the original source when the chemicals finally configured in a state of replication. But for 3 billion years, life was only in the ocean. And to me, that's like being in the trunk of a car. If you can imagine yourself, anybody as a kid have your big brother lock you in the trunk and drive around the neighborhood? It's not fun. And you have very little input. You're just feeling this banging around, but you really have no clue where you are or what's going on. And that's, to me, what ocean life was in the past, and that's what it is today. As smart as dolphin and orcas are, I don't think they have any clue that they're on a spherical ball flying at 67,000 miles an hour. But then we think that life migrated up onto land, and it's been here for about 700 million years. But just about all of that time, it was the orientation that we're not moving, that looking out of the back seat of a car, and as the stars and planets go by, you think that they rise and fall, the sun, the moon, and all that stuff is flying past us, and we're sitting here. So that was our state of orientation for 700 million years, until a crazy Italian guy came along. Galileo is credited. Of course, other people were looking at this too. But basically, the epiphany was only 400 years ago to say, holy cannoli, they're not moving, we're the ones moving. And the evidence didn't support it. There's more evidence that they're moving, not us. But basically, that's what our belief is now. So now we're in the front seat of this car for only a few hundred years, and now we're just realizing that we might run into something and it might be a really bad outcome. So the planetary defense effort of NASA has only been around for 7 years. So these guys are just getting the kinks out and I think trying to get some traction and figure out what they want to do. Here's another mental exercise. Is the prism of light that we discovered, a white light that we think is one source, breaks apart. If you think of the electromagnetic spectrum, we've discovered that it's actually an infinite inventory of all different frequencies of energy with different behaviors as far as how it interacts with matter and mass and transmits itself, and thermal effects. But to me, it's a fair assessment to think of the same thing of all human life, that we now know, or we believe, that every living thing that's alive today, including us and the fish and the beef that you might have eaten today, is all, and everything that ever lived on the planet for billions of years, is all coated with 4 nucleic acids, TCGA. But when those get broken apart, you have this analogy to the spectrum of light, that you have an infinite variety of life forms, but they're all coded off of the same source. To me, I mentioned before, I feel like it's whoever the creator is, it's like they revealed to us the Rosetta Stone of how they're doing this whole simulation of which we're a part. But the short message here, I guess, is that of all these billions of living things all over the planet, as far as we know, humans are the only ones that understand we're on this little ball flying through space together. And down here to support that unity of source, all of these little, embryos, from a fish to a chicken to a rabbit to a human, all look very similar until the DNA code runs, and then our gills move up into our ears and become our inner ears, but there's a lot of similarity of all life on the planet. So we're part of this unified spectrum of a life force. Find food, avoid becoming food, and reproduce. But we have this blessing / burden of the higher consciousness. So here's another way of looking at it, is that it's like a baby coming out of the womb, and we're just opening our eyes for the first time, trying to figure out what's going on. When they hit that DART mission that they thought was an asteroid, and then it behaved like a comet, to me proves we're just sticking our fingers into this pie, and we don't really even understand it. So we have an evolved consciousness over billions of years. There's a profoundly wonderful part of it, but tonight we have to talk about watch out. So the threat, let's look at that a little bit. Here's the main one, is we believe the caused the extinction of the dinosaurs. I've seen 5 to 8 mile estimate of the size of the object that hit. We know at 1992 the Hubble telescope discovered the Ceres asteroid that's 200 miles in diameter. So that's kind of an example of the potential risk. But we think it wiped out the dinosaurs. This is the site, Yucatan Peninsula, as the candidate site. But all over the world in general, there's a iridium metallic boundary that below that we find dinosaur fossils and above it we don't. Again, it's being studied a lot. Geologists are looking at different theories and things, but this is the consensus of that there was a mass extinction because we ran into something. Here's another example of that out in Arizona, a day's drive to the east. You could go look at this. You can't go down in it, but about 250,000 people a year go to the rim to kind of absorb this and take in what it means as far as the potential energy release of something hitting the Earth. Here's only about 100 years ago, Tunguska, Russia, flattened 80 million trees of 800 square miles. That's like driving, if you drive for 30 miles up to LA and then hang a right and drive 30 miles inland, that whole area would be about 900 square miles. If you imagine all of that got flattened on this one event on one day. Pretty profound energy. And they estimate that was a 200-foot diameter that exploded up in the atmosphere that never even hit the ground. In fact, I think there's some theories that they think it skidded out and went back out of our atmosphere and left the planet. We've all had bad days. This woman had Anne Hodges had a very bad day in 1954. She's the only known person believed to be hit by a meteorite. She was laying on her couch about 2 o'clock in the afternoon, and this thing came blasting through her house, bounced off the ground, and hit her in the side right here and caused a big bruise and damaged her hand. That's her house down in Alabama. There's a long story about they tried to sell this meteorite and get rich off of it, but didn't work out. And now here, this is the ground critical information to me. This was less than 30 years ago. Shoemaker Levy, those two guys, and Shoemaker's wife, I should have their first names, I don't have it on here, but they were right down in San Diego County at the Palomar Observatory with an 18-inch telescope and found this comet flying in 1993, tracked it, it was sucked into Jupiter's orbit and hit Jupiter with extinction level energy release, orders of magnitude of more energy than the entire nuclear arsenal of every country on the planet combined. It was over 6 days, 21 impacts. And here you can see the thermal imaging of the level of damage. It blew holes in at least in the upper atmosphere of Jupiter, larger than the Earth. Right? This is Jupiter and a scale representation of the Earth right there. So several of those blasts would have, if they hit the Earth, would have been all over. And that was less than 30 years ago. To me, we should have been ringing the general quarters alarm and really getting on this mission. And the scariest part is that I hear too many NASA people say, no, it's a very rare probability. We don't think it's gonna, yeah. Here's one only 10 years ago. I probably heard about this. Chelyabinsk, Russia. 1,500 people were injured. It blew up over the city. Not very big, 66-foot diameter, and 500 kilotons of energy released, 30 times the Hiroshima nuclear bomb. Here's one that actually one of the NASA telescopes that are dedicated to near-Earth object investigation found this thing, Oumuamua, out of Hawaii. They gave it a Hawaiian name because it was discovered out of the Hawaiian site. Only 6 years ago, they believe this came from outside of our solar system. It wasn't, most of the asteroid belt is all moving around the sun in the same direction as us, and they're tracking a lot of that. This thing was totally from outside of our solar system, went around the sun to hook the left, and also displayed non-gravitational acceleration. They don't know if there was an outgas or something, but they can't explain the physics of it. You know, once we detect an image, they're very competent at looking at data points and predicting its orbit with great accuracy, actually amazing accuracy. But this thing didn't follow that pattern. And to me, if you look at this, it was estimated to be about 10 times as long as its width, which isn't a natural formation. At the early development of our solar system, things coagulated and bonded together for gravitational forces, but they're generally some sort of round shape. That this, and I haven't seen anything written on this, but this suggests to me that that's a fragment of something that might have been much larger and exploded and blew off. This could be the first fragment of thousands that might all of a sudden show up in our solar system. We really don't know. So here's kind of a summary page. If you look at a risk assessment, the y-axis on the left, of course, is the severity of an event that happens. So if it's down here, it's a very low severity. If it's up high, it's a high severity. And they think roughly about a mile diameter or greater will be a catastrophic event to possibly extinction of all human life. And they're tracking over 800 of those objects right now that are near-Earth objects. And at the smaller level, there's over 10,000 that'll easily wipe out a city, 20, 30 million people. If it hits Shanghai, 25 million people wiped out in an instant. But then on the probability of that happening, smaller objects, because there's so many more, are a higher probability. So this oval represents all the objects that are flying around that we know of right now. And about 100 tons of dust every day enter our atmosphere, and we don't even notice it because it's so small, it just burns up and basically has no effect. But that's kind of the landscape of what we're working with right now. One note on that is the severity generally correlates to the size of the object, but then the composition definitely matters as well. If it's like Psyche of solid metal, that's going to have a lot more damage than a loose cluster of rocks and ice and air mixed together. So kind of a tough battle problem. This might jump ahead. Oh, sorry. Yeah. Okay, two more on the threat, then we'll get into what NASA's doing about it. This is a visualization from the Minor Planet Center. This is their data. That's up in Cambridge, Massachusetts. That's the center repository of all of these objects. They're tracking over 1 million of them, about 1.3 million asteroids in the inner solar system that are of concern, most in the asteroid belt. But there's about 33,000 of them within the orbit of Mars. What they call a near-Earth object is any object that comes within 1.3 astronomical units, where 1 equals Earth's orbit, 90 million miles. So 1.3 basically brings you out to Mars. So there's 33,000 objects within Mars' orbit that are worth being concerned about for high most likely potential of an impact. But there's a lot of stuff out there, over 1 million right now, and we're not tracking everything. There's probably order of magnitude above that, all within this region. But then thinking of that, all that we looked at on the last slide is within this circle right here, the inner planets. That's Uranus and Neptune, Jupiter, Saturn. We're doing this much tracking that's sitting right in here, that as Nick Timmons and others described to us, there's a Kuiper belt, a huge ice field in a disk shape, and then the Oort cloud that completely surrounds the sun 360 degrees with billions and trillions of ice objects out there. I think it was Nick that described, or somebody else earlier in the year, that they think that the mass bombardment, when things got really rough and we were getting hit every day multiple times, it was because another star or a large object came by and disturbed the balance of this whole system. So we're in a state of equilibrium right now, but you could probably make it valid that it's like we're a dandelion just kind of floating along, And any little disturbance could just blow this thing to smithereens and end the whole show. So to me, again, NASA's not taking this seriously enough. There's a lot of unknowns with the Kuiper Belt, the Oort cloud, and then of all of that's only 3%. We think that's only 3% of what's actually there. So you remember Don Rumsfeld said, hey, we know there's certain unknowns, but then there's also unknown unknowns. I think there's a lot of that out there too. So this whole initiative should kind of address all of that if we can. Okay, so that was the threat. Let's look at what NASA's doing. So that's their logo, Planetary Defense Coordination Office. I think I'm pronouncing it right, maybe not. Hic Salvare Diem. That's Latin, here to save the day. They understand that this threat is so large, it might save their mission is to save the Earth, which is quite a tasker. This is out of their study that I mentioned. Their latest publication was April of this year, their strategic plan. Basically, they have quite a few assets looking and searching. They understand we got to find this stuff, and we haven't found it all yet. The Minor Planet Center, that's where they do the main data collection and storage, archiving, and tracking algorithms. Over here, this is JPL. That's the Center for Near-Earth Object Studies. The guy, Paul Chodas, is in charge of that, where they do the analytical work and try and understand what we're looking at. And then there's other assets like Goldstone and radar telescopes, or radio telescopes, that can describe these objects in more detail for us. So then we look at the orbits and try and plan and coordinate with some international organizations and working groups. There's an asteroid threat warning center. And then any mitigation of which DART is an example, to go out and maybe divert something off its course so that it doesn't hit us. And then FEMA, as far as if we can avoid getting hit, mitigating the damage of notifying people. They're trying to work, there was that movie Don't Look Up, where they tell Washington and they don't believe them and some of that political stuff is relevant. Here's their charter, go find those things. If you go to the Minor Planet Center website, I think it's minorplanetcenter.net, they show you the daily updates of what they found and what the status is. Roughly 33,000 near-Earth objects, and then a subgroup of those is what they call potentially hazardous objects. That's anything bigger than 140 meters or roughly 500 feet and is on an orbit to come within 5 million miles of the Earth. And there's over 2,300 of those. Bennu is one of them that we flew out with the OSIRIS-REx mission, and that's what it would look like if it was sitting next to the Empire State Building. Kind of scary. Here's a little summary diagram. To me, from what I've looked at, these three, the repository of all the data, these guys coordinating resources, and JPL's brain trust of understanding what we're looking at and what the threat is that's the primary information sharing. But then these guys also network with international resources, civilians, universities are working. That Arizona site, some of the universities actually run these telescopes. Civilian amateur astronomers can give input to this. Anybody can give data points to it. It all gets qualified, but then again, they have to manage all of that. And then government agencies, to me, there's limited engagement. And these guys are just getting started, and everybody else has something that's a priority to them. So they're trying to build this network that's just kind of getting off the ground in the last few years. Here's the two key leadership guys. If you go on YouTube, you can see a lot of content from both of them. More so, I think, Paul, who, a scary statement to me is that he's saying that if we need at least 6 months' time to know of a threat that might impact the Earth so that we can schedule a launch vehicle, get something out there and divert it. If we have less than that, we could possibly send a nuke out to kind of take a broad brush at it. But other than that, there's not much we can do. That, as you'll see in the assessment, I think that's missing a lot of relevant information. Here's some of their primary assets. I mentioned this one in Arizona, the one out in Hawaii that found the large visitor from outside our solar system, And then there's an on-orbit NEOWISE that's infrared spectrum telescope. These three, on a dedicated basis, currently are finding over 90% of all the new near-Earth objects. They take multiple images of the sky, and then they see what moved, and then that's got to be in the solar system. Things outside of our solar system don't move that fast, so then they look at the contrast of that, and then look at it more closely, put other assets on it, and try and figure out what's going on. And their way forward, they had a big success last year with that DART mission. They flew, I think, about 7 million miles out, intercepted this asteroid, and another data point is they thought they were going to change its orbit by about 30 seconds, and it changed by about 30 minutes. So that implies that it was about 10 times less dense than they thought it was going to be. Not to mention that it grew a 6,000-mile glowing tail off of, and kind of became a comet. And we're finding with the sample that they brought back from Bennu on OSIRIS-REx that there's water in these things. So that may be part of what's going on here, is that the comets and asteroids are more alike than disalike. And then this is their new funded project. I think it's about $1.2 billion to put a new telescope on orbit, because a big challenge, like when the Russian Chelyabinsk came in, it came from the direction of the sun where we can't see these things. We only see the reflected light to identify them. So we're kind of blind as we go around the sun. So this is going to go into the L1 position inboard of the Earth, and it'll be able to see a lot more objects. It has a solar shield similar to the James Webb, and it'll look in the IR spectrum to try and do a better job of finding what's actually in our course of orbit. Okay, so that's an overview of the Planetary Defense Coordination Office. What I think are good things about it is that they recognize there's a threat that's very real, and they're not leaving it up to God. You know, somebody could say, hey, if the Earth blows up, that's what God wanted, but we shouldn't interfere. But, you know, there's that demarcation between faith and prayer and being proactive on something or letting it take its own course. But I'm glad to see that there's a lot of resources now, and more every day, trying to address this issue. And they understand that detection is key. If we don't see it coming, we have very little chance of addressing it. And then the DART mission showed a lot of technical competence, that we can identify these things, track them, and fly out there and intercept them if need be. But what's more important than the positive on it to me is the shortfalls, if you will, or opportunities for improvement. Number one is the threat may be much larger than what they're diagnosing. They're saying we're tracking 50% of what's around us, but the threat may not be around us right now. It can show up out of nowhere, and we should have capability to address it. They have no mention of lasers. They talk about intercepting these things, and if it's short notice, we might have to put a nuclear warhead on the front and use that methodology. But lasers are a proven technology that seem very appropriate to apply to this battle problem. And the complete document has no mention of it. We could get into the politics of that, but and let me just say, like the Germans, when they made the V2 rockets, they didn't tell everybody, hey, we're making a rocket that's going to be able to fly with no pilot, go 100 miles and blow people up. They wanted that information secret. If somebody has weaponized lasers out in space, they don't want to tell everybody, hey, look what we can do with these things. They want a competitive advantage. Some people live their lives every day in a warfare state of mind, and if they can have a leverage over anybody that they perceive as a threat, they're going to do that. So I think the missing of the lasers isn't a technical oversight. I think there was a political oversight that said, you're not going to tell the world that there's weaponized lasers out on orbit. Just a theory, but I'm kind of a conspiracy theorist. And then they have no details on survivability. That I have a couple thoughts on that. And we'll look at these a little bit closer. And no details on redundancy. Every military organization and political and others, you make redundancy, you have a backup location or a backup capability. Ships are designed that the left side has the same architecture as the right side. If you take a hit on the left, you have communication systems and capabilities on the other side that'll still be able to operate. So looking at that on the, that the threat's much greater than they're assessing, to me, again, several of these comets would have ended all life on Earth based on their calculations of the amount of energy released. So to me, if you're planning to survive something like this, and they didn't know this was coming until a year before it showed up, would be to, as a goal to say, we want the Earth to be able to defend against 10 of these things simultaneously. And that may sound hard, but it may be easier to do than you might think as well. We'll look at that a little closer, but I think that would be an appropriate defense strategy. With the big the big tool in the toolbox that they're not leveraging are lasers. That's light amplification by stimulated emission of radiation. These things are ubiquitous in our lives now. I had the laser surgery on my eyes, vaporized part of the cornea at 20/20 vision. Every cell phone communication just about goes on a fiber optic network with pulsed lasers on it, and we'll look at that a little closer. But these things have unlimited range at the speed of light. Why would you want to fly out to something if you could zap it with a laser, which is applied science right now and available? And if you hit it the way this diagram kind of illustrates, if you gas out, and that creates a local thrust right there. You have like a rocket motor thruster, which is basically expanding hot gas, and then you drive that thing one way or the other. And then even beyond that, we're talking about big snowballs, basically ice that you can vaporize, the comets, and even most of these asteroids we're finding are low density with a lot of water content. We could break these things up and put them down on that risk probability scale of something that's survivable rather than an extinction event. And again, these things are not only available, they're operational and deployed. The Navy has multiple ships around the world using lasers that can burn through steel in a matter of seconds. Hitting an asteroid or a comet, that's low-hanging fruit. Those are soft targets to some of the stuff that our military has today. This is an airborne laser that's fast enough to shoot. We have ones called THAAD that are, if a large rocket or threat's coming in, it can shoot it down. The airborne laser with the Air Force, that's designed to fly around the Korean Peninsula and take out a ICBM on launch sequence. Within seconds of coming out of a silo, that thing can neutralize ICBM rocket, burn right through its steel casing and blow the thing up before it even gets off the ground. Seems like we should be using that to save the planet. In fact, here's an illustration of that. We talked about the threat profile. That's the existing threat profile. If we use lasers and fly some things out there with the tasker of go find these big objects and bust them up into little objects, we could put this whole threat spectrum below the extinction line. It seems like we should be on this quickly. We have the tools sitting right here off the shelf ready to go. And as far as I can tell, we could go do this. Okay, then survivability says, say we can't protect ourselves, we get hit by an extinction event. Are we all just going to perish and say, well, we tried and it didn't work out? No, you should have people, and actually there's other military agencies, they call it COOP, continuity of operations, that if somebody blows up Washington, D.C., the government doesn't disappear. They have backup plans, Cheyenne Mountain for one, and other locations to survive a nuclear blast, actually. And submarines are a very good candidate for doing that. I deployed on a sub. They go out with 6 months of food supplies that if you modified, we have over 50 nuclear submarines that we decommissioned after the Cold War. We had about 130, I think, under Reagan, and now we have about 40 operational. There's 50 that are mothballed. That if we took out all the weapon systems and put food stores in there, you could have a 10-year supply on those things. So we'll talk about that. Actually, let me go to the next slide. So you take a small fleet of submarines, convert them for survivability, you put some of our young kids, or the crew composition will be determined There's a lot to learn, but we modify it, take out the weapon systems, you put some gym facility in there, a pickleball court maybe. You have a movie theater and a 10-year food supply, and you send these young patriots out on a 3-month deployment basically. So they pull out of San Diego, go tool around on both sides of the equator, and come back in 3 months, and they're national heroes. That they're the Noah's Ark project. That if all shit hit the fan and we destroyed the atmosphere, they get ordered to stay down there, and they can stay down there for years and wait till the air is breathable or the radiation is low enough, or find a spot on the planet that in New Zealand or someplace that's habitable, and they come up and humanity survives. This is, compared to the national defense budget, this would be a very low-cost operation to implement. And this also, we would learn a great deal. Not everybody's cut out to go in a submarine. I have a psychological testing to go serve on a submarine, but we would find things out of what goes well, what doesn't go well, that this would be a stepping stone when we colonize other planets. You need people that know how to operate together, can handle that semi-isolated environment for months at a time, where you can't get in a fight with your boyfriend and just run out the door and run down the street. So this is all doable, and again, it'd be a small fraction of our national defense budget, and I think very practical and doable. And the data that we get, the critical learning of people, we may find even they want a bunch of old people on there too. We may have some tempering effect to help the crew stay together and put the squabbles to bed. Or what's the ideal composition though, and of types of people, gender of people, and all of that stuff. And how much exercise they need, how much rest they need. There's a great deal of learning for, if we're going to fly to Mars on multiple missions of people, they have to be certified with this first. And when they come home, they're respected more than the Navy captain or anybody else that's serving their country. This is a service to all of humanity to ensure we survive. These people would be national and international heroes, or at least they should be. And then redundancy. Elon Musk is credited with all single planet species go extinct. But basically, we have all our eggs in one basket right here. Just a little bit on that, but it's that the concept is to have a backup planet. We need to go colonize the moon and Mars on a permanent basis. And two benefits of that, besides the redundancy, if you have a 1 in a million chance of getting taken out, but if you have two locations, it's 1 in 1,000 billion chance of both of them getting taken out. So again, if we want the human species to survive, this would be a good strategy, having some redundancy in our location. But on the speed factor, we go about 67,000 miles an hour. The Mars is in the next orbit out of ours. They go about 54,000 miles an hour. And if I do the math right, little mind exercise, think of driving down the freeway at 70 miles an hour, and some yahoo comes by you at 90 miles an hour. You think, that guy is nuts, he's so dangerous, he's gonna kill himself or somebody else, that idiot. Well, that's what, Mars is going about 70 miles an hour, Earth is the one going 90 miles an hour. As far as having time to respond to something in front of you and address it, Mars would be a beneficial location just for that factor. And then the other factor, by a factor of 4, it's 4 times smaller cross-sectional area. So just raw math, like if you're throwing darts at balloons on a dartboard, you're gonna hit this balloon 4 times as often as you're gonna hit that balloon. So both size, speed, and then the pure redundancy is pretty compelling for us to pursue this. All right, so a few concluding thoughts. It's about 45 minutes, and then any questions or discussion. I'm very interested if anybody has any feedback on this. But in conclusion, we absolutely need a planetary defense strategy. I think what we have right now is lacking a lot of forethought and vision and coordination. We have a long way to go. But I'd recommend we build and deploy scout lasers and put them all at the Lagrange points. So we have, if something comes up unknown, we have laser capability 90 billion miles in front of our orbit. We have 2 battle group wingmen 1 million miles on each side of the Earth. And then on GEO, at about 20,000 miles out, like circling the wagons, we have lasers all the way around Earth and pointing outward in every direction that can take a quick response. And then we already have operational anti-satellite weapons, and THAAD, I guess I didn't mention before, that stands for Terminal High Altitude Area Defense. We have weapon systems that can fly into outer space 100 miles above Earth and intercept any ICBM or other fast mover out there. So these are all operational and running right now for different applications, but they should be addressed to this mission as well. Some random thing coming and trying to give us all a bad day. So what that would look like is a layered defense operationally. So we have satellites with lasers that go out and hunt these larger asteroids and bust them up. I call those hunters, all the way out long range into the asteroid belt as needed, and neutralize the threat before it has a chance to hurt us. And then L4, L5, those are scout areas, about $90 million range. Mentioned the L1, L2, figuratively about a 1,000,000-mile range out. Then we have the GEO array that's 20,000 miles above Earth, but they could shoot, actually indefinitely, but they could engage. And then the two that I talked about. And then absolutely worst case, if something got through all 6 layers of this defense system, that we could probably build and have fully capable within 10 years if we got serious on this stuff. But then we have the survivability and the redundancy factors as well. All those things should be pursued right now. So for the Planetary Defense Coordination Office, I think they really need to overhaul their strategy and action plan. In fact, I don't want to sound cruel. These are technically trained people, competent, probably very dedicated to their work. But if you gave a bunch of 5th graders the task, hey, there's asteroids flying around that might hit the Earth and cause us to go extinct. How are you going to defend yourself? I think the lasers would jump out at you as a #1 capability to at least explore. So I think they should have a laser intercept verification experiment. They love acronyms. That would stand for LIVE, which is what we're trying to do here. And go out and demonstrate that we can bust these things up and see what the effects are, though. There may be some unknowns that's not as good an idea as we thought or whatever, or here's how we can do it more effectively, or we need multiple lasers from different angles. But one opportunity for that, in about 5 years, Apophis is coming by, pretty large PHO, potentially hazardous object, within 20,000 miles of Earth, that if we waited for that to safely pass us and then engage that, we can have all kinds of eyes from Hubble telescope, James Webb, hundreds of Earth-based telescopes, could all watch what happens when we engage this thing, so we could, again, learn the process and understand it better and then build off of that. But not only are they not doing that, Stuart and I went up to the Orange County astronomy, and a guy did a presentation on this mission is active and funded and running with dozens of technical experts. It's called LISA, Laser Interferometer Space Antenna. These guys, they know lasers work. They want to build 3 satellites that go out behind Earth's orbit and follow us in our orbit, and at 1.5 million miles apart, shoot a laser at each other at about a 3-inch cube. They want to suspend these cubes, have them not touch any other part of the satellite. They're just kind of flying through space, and use lasers to billionths of an inch of accuracy measure if these things move, so that they could identify gravitational waves. If they see one disturbance over here and then the other one, and how much time was it, but gather analytical data. But basically, they're underway building satellites with lasers on them because they want to find gravitational waves. But the analytical problem of that is huge. Like, to know whether that was an asteroid passed by or something else caused that disturbance. There could be a whole lot of things that the value of that information, to me, is way beneath what the value of this mission would be. That I would support scrubbing this thing immediately and put all the resources onto this of something practical that could save 8 billion people on the planet. That This is almost like if somebody was looking at the earth, like, and like a child playing t-ball for the first time. He's supposed to be focused on the ball coming out to right field, and he's over there looking at the flowers and the bird flying by, like his head's not even in the game. If somebody looked at humanity right now and understood what kind of risk we're accepting flying through space, and we're doing things like this instead of things like this, it's pretty scary. You can laugh at it if you want. I lost a really good neighbor. Henry wrote. He made it to 99 years old, and a couple months ago, the nurses said, "Henry, you had such a great life. What's the secret?" He said, "Be nice to everybody and don't take life too seriously," which I thought was pretty profound. That you can get spun up on things, and it's I'm not saying don't focus on stuff and apply your skills and talent, but in the big picture, it's a good chance this is some kind of simulation. That we're just a part of this experiment. But anyway, I think that's really important. I think the Noah's Ark demonstration for the survivability is something that at low cost we could start doing. And then basically what they're missing big time is the Department of Defense have cadres of people that are experts at this kind of risk assessment, threat assessment, and then mitigating factor development, and could get on this. And that's the mindset that this battle problem really deserves. And they're missing that right now. So imagine if our Department of Defense, they get about $800 billion right now, and the only justification for that is war. So they're kind of incentivized to make war. If they don't make war, all their jobs are kind of irrelevant and go away. We got a problem. There's something to that. But if we did a major overhaul and said, our Department of Defense, your #1 mission is planetary defense. NASA has separate offices across town for this Planetary Defense Coordination Office. By the next year, they should co-locate into the E-ring. The biggest ring of the Pentagon should be dedicated to planetary defense. Bring all that talent and knowledge and tap into them as needed. And figuratively, that should be the #1 funding line and priority of this big office building here. They have over 6 million square feet. If they don't have war with somebody, people are going to be saying, what are we doing with all this money? I would cut it to like $500 billion, and Space Force and planetary defense get joined at the hip and really tackle this battle problem that we have that's a real threat from off the planet. Yeah, we still need national defense, but anyway, I won't get into too much of the other organization, but we could be applying those precious resources a lot more effectively. And then I've occasionally thought of what he's occasionally thought of. I always liked in the 80s, at the height of the Cold War, when the Soviet Union was in Cuba and South America, Nicaragua, and we all had all this chaos and mayhem. And he said at the United Nations that, imagine if there was a threat from off the planet, how humanity, all these differences would vanish in a second and we would be unified. That's what this educating people about what this real problem is, and this threat from off our planet against all of humanity really can have that effect of bringing us together and realize we're more alike than different. So another way of stating that is, here we are all flying on this little ball together, a planetary defense mission to save 8 billion humans that makes us more humane at the same time. It's kind of sometimes a negative is a blessing and the other way around, that this challenge could really help us as far as our consciousness and how we treat each other overall. So bottom line, the threat is urgent, we have the means to address it, and we need to get our heads in the game and get this thing done. So with that, I thank you all for coming, and live long and prosper. Less than an hour. And thanks again for coming out. Hopefully it was worth it.